A lot of students seem to struggle with applications, so in this video I wanted to take a look at two such applications that seem to give students a hard time, so that you can see how to attack these problems in the easiest way possible. Now remember, there are millions of approaches that can be taken, so if you don't like this approach, please feel free to search out another approach. Or if you have any questions or need further examples, please let me know either via email or in the comments below. And I would be happy to work those out for you. However, these are just two of the most troublesome applications that I have seen thus far that a lot of students seem to struggle with. So the first one says that you have a circle with a 10-foot diameter and an arc of 20 feet long. And it subtends an angle of how many radians. And so it also wants to know how many degrees and to the nearest degree. Okay. So the first thing I would suggest is just draw yourself a mini circle. It doesn't have to be perfect, just so that you can kind of get an idea of what's going on. So here is my mini circle. And so what we're doing is we're going to put in the information we know, which is that we have a diameter of 10 feet. Now, one of the things that we know about diameter is we know that diameter equals twice the radius, which means to find radius we simply have to divide by 2. So in this case my diameter was 10. So 10 equals twice the radius, divide by 2, and we end up with 5 feet equals my radius. Now I'm going to kind of set this aside for later. And the other thing that we have been told is that we have an arc length of 20 feet long. So we don't know exactly how long that is, but we do know that we do have this arc length here, okay, that we are kind of working with, and we are told that it is 20 feet. Okay. Now essentially what we need to remember again is that we have that fun formula. Angle is equal to my distance over my radius. And so in order to find my radians here, we need to take my distance, so I know that it is 20 feet, and divide it by the radius, which we already calculated to be 5 feet. And in this case, you are going to end up with 4 radians. Now, it wants to know not just how many radians, but it also wants to know how many degrees. So we need to be able to convert to degrees. Again, to do that, says we take our radians, so this is 4 radians, and we're going to multiply this by 180 degrees over pi. And when we do that, we are going to go ahead and come out with roughly 229.18 degrees. However, we want to the nearest degree. So when we're looking at 0.18, what we can notice about that is that it is definitely, the 1 is less than 5. And therefore the rounding rule says if you're less than 5, you round down or stay the same. So in this case, we would have that the angle is 4 radians, or 229 degrees. And this would be the answer that we were looking for. Alright, now for the biggie. So assuming that Columbia, South Carolina and Daytona Beach, Florida have the same longitude, which is 81 degrees west, use a radius of 6,370 kilometers for the Earth, and the following to find the distance between the two cities. So it says that we have Columbia, South Carolina has a latitude of 34 degrees north, and Daytona Beach, Florida has a latitude of 29.29 degrees north. Now, with this information, there is one important thing that we need to remember. So we have this note here, and that is that when you're dealing with the southern hemisphere, it is automatically considered negative. Okay. So when we're dealing with that southern hemisphere, we are automatically assuming or working with negative numbers. So we need to look at what actually do we know. Well, first of all, we know our radius, and that's going to be 6,370 kilometers. We also know that that was in reference to the Earth itself. Now, that being said, we have to take the latitude of South Carolina and we're going to add it to the latitude of Florida. However, we need to remember that Florida is in the southern hemisphere. So that being the case, when we say 29.25, we're really talking about negative. So here we have to be able to combine these together. So in order to do that, we have South Carolina, which is 34 degrees, and we're doing north. We are adding this to my negative 29.25 degrees north for Florida. And this is actually going to give us an overall of 4.75. Okay. Now the last thing we need to do is we need to be able to calculate our theta. So if you remember, your theta is going to be S over R. But in this case, what we're dealing with here is we are dealing with degrees. And remember, theta must be in radians. So before we can do anything, we have to convert. So we need to change our theta. So we need to change that theta has to be the 4.75 degrees times pi over 180 degrees is going to give me my radians. So I'm going to use 0.0829, and this is radians. So if you look at what we have our radius here. We have a theta here. The only thing that's missing is the distance, which is what we wanted to know. So to find it, again, we're going to go back to our formula, which says S over R. The part that's missing is S, so I'm going to go ahead and multiply everything by R. So I get that S is equal to theta times R. Plug in the information that I know. So I have 0.0829 radians times 6370 kilometers, and this is going to give us our distance. And so in this case we end up with S being 528.10 kilometers. And this is what we wanted to find. So with this problem here, the biggest thing that we had to keep in mind to remember is that when you're dealing with the southern hemisphere, you are automatically dealing with negative numbers. It is assumed that we know and recognize that the number you see is a negative value. Okay, so as long as you remember that rule and have a general idea on where some of these things are located, meaning you remember or recognize that you're in the southern hemisphere, well, then you won't have any problem. Now, that being said, if both of your values fall into the northern hemisphere, then both of your values would have been positive, so then this would have been a straight addition problem. So if you just remember you're doing one plus the other, and the hemisphere location is going to determine the sign, you are good to go. So if you have any questions on those, please let me know. Otherwise, I hope you enjoyed, and I'll see you next time.